All right, section 11.5. 11.5 is all about tangents. Now, when we talk about tangents and circles, this is different from the tangents we had when we were doing our trig unit. A tangent is a line that touches one circle in exactly one spot. Okay, so if I wanted to, I could take this segment AB and I could turn it into a line. This goes straight across. That line only touches the circle right on the outside edge of the circle and nowhere else. Whereas the chord passes through, or a secant is a line that passes through a circle and touches it in two spots. Tangent, only one. Now, what's nice about tangents is every single tangent in a circle, if you draw a line from the point of tangency, from the center of a circle, if you make a radius, this always makes a 90-degree angle. Okay, so for this one, we know that BA is a tangent on circle C. Point of tangency is at A. So this point right here, they want us to find X. Okay, we know that, this makes a triangle ABC. Every single triangle angle measures add up to 180 degrees. So if we have 90 degrees here, we have 22 degrees here. This just has to be the remaining 58 degrees. So X, this equals 58 degrees. It's that easy. Now, on this next one, a little bit different. We have two tangents. Okay, so PA is a tangent, and PB also another tangent. So their point of tangencies are right here. So since AC and BC are radii, we know that this is a 90-degree angle, and that's a 90-degree angle. Okay, this looks like 90-degree angle, but it's not. This is 92.8. We have to be careful. Now, on the last one, we had a triangle. Triangles add up to 180 degrees. Think back to our quadrilateral unit. Quadrilaterals, their interior angles add up to 360 degrees. So we know that 92.8 plus 90 plus another 90 plus X equals 360 degrees. All right, so let's just do quick math. That gives us 90 plus 90 plus 92.8 gives us 272.8 plus X equals 360 degrees. Right, so subtract 272.8 on both sides, and we are going to get X equals, I think that's 87.2. All right, circle O has radius 5. Point P is outside circle O, such that PO equals 12, and point A is on circle O, such that PA equals 13. Is PA tangent to circle O at A? All right, there is a lot going on here. So let's start off. I'm drawing circle O. So there is perfect circle O. Let's see, this thing has a radius of 5. So I'm going to call that radius of 5. We know that point A is on circle O. So what we can do is let's go ahead and call this point A. O, or let's see, point P is outside of the circle. So let's just go ahead and put it right here. There is point P. We know that OP has a length of 13. No, we don't. PO has a length of 12. PA has a length of 13. What they want to know is this 890-degree angle. Okay, so if you focus in on this triangle right here, this 5, 12, 13 triangle, in order for AP to be a tangent, this angle right here must be 90. Okay, but looking at this triangle, you know right off the bat something is wrong, because 90-degree angle, these two angles have to be smaller than 90 degrees, because a triangle must add up to 180 degrees. All three of these angles need to add up to 180. If this is 90 degrees, then these two have to be smaller than 90. Okay, so what's wrong with this triangle is that the opposite side from the 90 is 12. Okay, since 90 is the biggest angle in this triangle, then this should be the longest side of the triangle. This should be the hypotenuse. But notice how we have this 13 right here. 13 is obviously bigger than 12. So there is no way for this angle to be 90 degrees. All right, so if we had to redraw the circle so it looks somewhat correct, we would have our radius of 5 here. And this would have to be our right angle. So this would be our length of 12, and this would be our length of 13. This is really what it would look like, since 13 has to be the longest side of the triangle. So this is our 90-degree angle. We don't know what this angle is. We don't really care where that angle is. We just know that it is not 90 degrees. So this segment right here, this segment AP, cannot be tangent to circle O. All right, here we go. AT. Segment AT is tangent to circle C at point T. Point T is our point of tangency. AT is twice as long as AP. Okay. So AT twice as long as AP. Circle C has a radius of 3 inches. Okay, so let's look at this. I don't know how long PA is. I don't know how long TA is. All I know is that AT or TA is twice as long as PA. So here's what I'm going to do. I'm going to say that PA or AP has a length of X. Therefore, TA or AT has a length of 2X. We know circle C has a radius of 3. So this segment right here is 3. And this segment right here is also 3, because all radii in a circle are congruent. Since AT is tangent to circle C, we know that angle CTA is a 90-degree angle. All right, and we can use this. We have a right triangle here. We can use the Pythagorean theorem to solve for x. Okay, so what I'm going to do is I'm going to draw just a right triangle. Here's my 90-degree angle. Keep in mind, CA is our hypotenuse. All right, so if CP has a length of 3 and PA has a length of x, then this entire thing, C to A, has a length of 3 plus x, or you could say x plus 3 if you wanted to. TA has a length of 2x, and there is our 3. If we had to label this thing, we would have this point T. Here's our point A, and here is point C. Now, let's just use the Pythagorean theorem. We know leg squared plus leg squared equals hypotenuse squared. So 3 squared plus 2x, that entire term is being squared, equals, I'm going to call this x plus 3 instead. X plus 3 squared. Since they're being added together, I can do that. So what we have is 3 squared is 9 plus 4x squared equals, keep in mind, x plus 3 squared is x plus 3 times x plus 3. So what we can do is we can double distribute, and that gives us x squared plus 6x plus 9. So now let's go ahead and move everything to one side. I want to keep the x squared term positive, so I'm going to move all 3 of these terms over to the left side. Okay, so luckily, our 9s cancel each other out. So let's just subtract x squared, subtract 6x on both sides. What we are left with is 3x squared minus 6x equals 0. And we can factor this. So this isn't a trinomial, it's an easy kind of factoring. Let's just pull out a greatest common factor, that GCF being 3x. What we're left with is x minus 2 equals 0. So now let's set both of these terms equal to 0. So we have 3x equals 0, therefore x equals 0. We have x minus 2 equals 0, therefore x equals 2. Now, we are not done because directions wants to find AT and find AP. All right, so let's just plug in. Now, having x equals 0 is fine as long as you plug it back in and it works. But in this problem, if we plug in x equals 0, what we're going to end up with is segment PA has a length of 0, and segment TA also has a length of 0. You can't have a segment with a length of 0. So x equals 0 does not work in this situation. But if we plug in the 2 here, what we're left with is PA equals 2, and TA equals 4. So, looking at this triangle, this is a 90-degree triangle. What we have is 3. This whole segment right here, 3 plus x, that turns into a 5. And TA has a length of 4. That is a 3, 4, 5 Pythagorean triple. So this ends up working. So x equals 2 is a correct answer. That is a possible solution to this problem. All right, last one. This is a good problem. This thing looks like we have a point of tangency here, a point of tangency here. That's a 90-degree angle. That's a 90-degree angle. Therefore, since these two are 90-degree angles, these segments, we don't have letters on these things, but I'll call this point C and point D. All right, so AC and BD are parallel. So if you wanted to throw those in there, let's see, we have a radius of 4. So what we can do is we can call that segment 4. This circle, circle A, has radius of 8. So we can call this 8. Therefore, this entire segment here has a length of 12. Right? But what we need to do is we need to solve for x. We need to solve for segment CD. Now, how the heck can we do that? Well, here's what we're going to do. I'm going to draw a line like that, such that it is parallel to CD. All right, so we have opposite sides are parallel. Therefore, let's see, we have this parallelogram here. Therefore, in parallelograms, we know opposite angles are congruent. So we have a 90-degree angle here. We have a 90-degree angle here. Since we have a quadrilateral, a parallelogram with 4 right angles, this is a rectangle here. So I know that opposite sides are congruent. So if this segment is 4, then this segment right here is also 4. Okay, so if this segment right here has a length of 4, then we can say this has a length of 4 because this whole thing has to add up to 8. Now what we can do is we can focus in on this triangle right here. If this is a 90-degree angle, then that one must also be a 90-degree angle because they are a linear pair. So here's what we can do. Let's focus in on that right triangle. We know that we have a length of 4 here. We have a hypotenuse 12. Since segment CD is x and this is a rectangle, we have that this segment here is also a rectangle. Therefore, the second leg on our triangle is also x. And now it's just a matter of doing Pythagorean theorem. So we know 4 squared plus x squared equals 12 squared. So we have 16 plus x squared equals 100. and 44. Therefore, x equals 122. Go ahead and square that. We have x equals square root of 122. I don't know if that breaks down. So why don't we just go ahead and get a decimal for it? Square root of 122, that gives us 11.04. Okay, so this segment CD, equals 11.04 units. All right, and there we have it.